Hello and welcome to this first lecture on C#. In this one, we're going to be giving all the basics a programmer has to know before working with C#. Before we get started, let's talk about some stuff C# offers and give some of its background. So C# is a multi-paradigm programming language, which means that it has a lot of paradigm programming features such as structured and concurrent programming. It also supports event-driven and task-driven features. And, it is also used for many of the applications we see nowadays because it's the language that is supported by Xamarin, which is a cross-platform app development tool which uses the CLI with a C# shared code base. Using this tool, developers can write native Android and iOS apps with the same interface. It's written in C#. That's what's cool about it. Another motive for C#, it's the language of .NET frameworks. It gives you the power to create a website from the bottom up. So what I mean from the bottom up is, what you see is the top, right? So it's HTML/CSS code, all this scripting type of stuff. Well, you can actually set up a database using C# and only C#. That's what I mean. So that's what's so cool about it. You can actually build an application and a website and, feed it all the functionality using only this language. This is really a nice motivation to get started with C#. Now, let's continue with the history. It was developed and led by Mads Torgerson, developer at Microsoft. As you can see right here, this is his Twitter account, right? He's the C# language PM at Microsoft right here. This is his GitHub account, right? So yeah, go figure. So why is this language popular? It's intended to be simple. It's really easy to learn. The language provides support for software engineering principles such as strong type checking, array bounding checking, and also automatic garbage collection. And this will give the software more robustness and durability. Now, since it's designed and developed by Microsoft, Microsoft is going to impose an IDE on us, and the best IDE for C# purposes, from my experience, is Microsoft Visual Studio, and it's what you see right here in front of you. If you don't have it, you can just visit their website, which is right here, and according to your machine, it will download depending on your operating system. So I've got a Mac. In that case, I will download Visual Studio for Mac. You just follow the setup instructions and you're done. There's one for Windows, there's one for Linux. As you can see, it has a lot of really cool features. Also use it for DevOps purposes. So without further ado, let's start by printing something on the screen. So the way you do that is using console.writeLine. Let's say you'd want to print welcome to this tutorial. So this is simply how you print something on the screen, and let's run this program, and there we have the output. Now let's say you're interested in interaction. You would like to read some input from the user. And the way you do this is always using a string. String input is console. Instead of writeLine, you would have readLine. So readLine as such, and after the user enters something and then hits enter, the input is stored within the variable input. This means that you can use input in, other variables and other scopes of your program to your own good. So let's see how this works. Let's say I would like to read the name of the user. So instead of input, I'll put name. I'll call it name for sake of organization. Console.writeLine. Hello. Now we're going to do string concatenation. We're going to see that also later within this tutorial. So how we do that is as such. Hello is a string. Name is a string. When there's a plus in between two strings, it means they will be concatenated. In other words, they will be placed one next to each other. So running that. Welcome to this tutorial. Please enter your name. We're at line 10 at the moment, right? Line 10 has been executed. It is here. And then the program is waiting at line 11, waiting for the user to enter some input. And now let's enter a name. Let's say Ahmad. Enter. And the program has been terminated. Notice that line 12 printed hello plus my name. So this is how you basically read and write to the console. Writing to the console using write line and reading from the console using read line. So you'd like to read a line from the console. Next off, let's talk about data types. Let's start off with the most basic data type, which is an integer. So the keyword to define an integer is int as such. Int x is equal to 1. In that case, x would hold the value 1. To see that, all we have to do is just, type it on the console. There we have it. Let's say we change the value of x somewhere else within the code. Console.write line x again. There you have it. We have 1 and then 56. Now, the maximum integer you have within C#, you could extract it as such. So int dot max value. This is the maximum integer you can define within C#. Let me erase everything here and just print this out. It is this value right here. As you can see, it's naturally big. So you've got the max value, and if you also got the min value. So running that, it's the negative of the max value. Okay, so that's it for integers. Let's talk about something else, which is floats. So floats contain decimal values. The way you define a float is float x is say 4.5 as such. And as you can see, I have an error over here. Proper way to define it is by ending with an f as such. So printing that out, we'll get 4.5. Let's say you would like to extract the maximum value of a possible float. It is this number right here. And you also have the min value, which is the negative of the maximum value, right? So floats are 32-bit numbers, have more precision, of course, due to their decimal nature, and their precision is up to 7 decimals. So we have 7 decimals of precision. Now, if you want to go higher in precision, you can use something called a double. So what doubles are, so double y is, let's say, 5.9 as such. Console.writeLine, say y. There we have 5.9. The maximum double you can have is following number. You can go up in precision. The minimum is, of course, as we saw, the negative of the maximum, as you can see here. Now, let's say you're in a situation where you have a float, you have a double, and you would like to add them up. So let me comment this out and this out. So indeed, if you would just add x with y, let's see the output, 10.4. So you can really just go ahead and add a float with a double. There's no problem with that. Let's say you have an integer, so int z is 1, and you would like to add an integer with a float. So instead of y here, I have z, run, and there's no problem at all. You can go ahead and add an integer with a float. And also, you can go ahead and add it with a double, 6.9. We didn't say anything about doubles. Doubles are also 32-bit numbers, but they require, or they have a precision up to 15 decimals. So we have 15 decimals of precision, almost the double of a float. So those are 3 really important data types and used extensively within applications and so forth. Next off is long. So long is also a data type. Long, let's say I want the maximum long that I can get. So it's a long.max value. And let's print it out. Console.writeLine. This is the maximum long you can have. So long is also a data type. And you also have one more important data type, which is a decimal. It's even bigger than an integer. So decimal max is decimal.max value. Let's call this max decimal. And let's just print it out. There you have it. It's longer than the long. And could decimals have decimal A is, could they have decimal as one might think? No, they're only integers, okay? But they're allowed to range more than integers. So comparison among max of each of the following. So they're all integers, but each one is longer than the other. It means that they are allowed to span more values. To demonstrate this, int max value, let me just copy paste this twice. So long and decimal. Run. Of course, this is an error. Let me remove it. Run. And take a look at the last 3 integers that are being printed here from lines 32, 33, and 34. So as you can see, the maximum integer is the following, the maximum long is the following, and the maximum decimal is the following. If you're sure that your variable might take a value larger than this, you can just go ahead and use a long. If you're sure that your maximum value of a variable could be more than this, you can go ahead and use a decimal. Now let's talk about characters, which are 16-bit Unicode characters. So character is just a character on your keyboard. So let me show you what I mean. Say I have a character A, which is, I don't know, the letter E, for example. So if I go ahead and print it out, I will get the letter E as such. Now the other outputs are getting really annoying. We're done with all of those. I'll just comment them out and let me rerun. There you have it, E. This takes us to the other data type, which is strings. And a string is nothing other than a concatenation of characters. Let's say my name, and we have an error because I didn't mention the name of my variable name. And the other error comes from using a single quotation. Instead, for strings, we have double quotations as such. Now let me print it out. There you have my name under the character. So really, those are all the basic data types. We started with integers, then moved to floats, doubles, longs, decimals, what else? Characters, and finally strings. Now there is one more important thing that is worth noting or mentioning, which is the keyword var. Now var, once I define a var as such, var is an adaptive data type, means it could take a double or an integer or maybe a string, I don't know, but its data type cannot be changed throughout the program. So let me show you what I mean. Once I define it as such, let me just go ahead and print it out for you. It's 1. And now let me change its value to 2. Let's see if there's a problem with that. There's no problem. So 1, then 2. Good. Now let's go ahead and give it a decimal. So let's print that out. And as you can see, you have this red marker right here saying cannot implicitly convert type double to int. So C# right here understood that this A is an integer. Let me just change it to a double and voila, the error is gone. There you have it, because at initialization the variable was seen as a double. Once I do this, at initialization, A is seen as an integer. Now what about if I do this, A as such? We have an error right here. If I run, the error is saying that implicitly typed variables must be initialized. Now what implicitly means here is that C# implicitly infers the data type upon initialization. So right here, C# understood that A is a double. As such, A is an integer. As such, A is a character. Okay, so once I run, the compiler is going to yell at me right here saying cannot implicitly convert type int to char. Okay, because it's a character. So if I do this, let me change it to B and here to, I don't know, C. I should be able to see ABC, right? So that's it about var. After you initialize it, you could go ahead and change it throughout your program. And why am I saying this? Why am I saying that, oh, I can go ahead and change it as such? Because we have this other data type called const, which means constant. And once you define a const, you cannot change it within your program. Look here, you have an error upon compiling, which is the left-hand side of an assignment must be a variable property or indexer, because it's a constant. Once I remove this, all is good. Program will compile. Now, when do you want to use const? It's when you have constants. So let's say you would like to define pi somewhere within your program. It's 3.14 and you're sure that pi is not going to, be mutuated or changed throughout your program. So you just go ahead and say that it's a constant. Now, let's say you want something like a var, but you want to be more flexible. In other words, you would want a variable to be a string and then at the same time an integer, and you would like to switch around. Well, you can go ahead and instead of using var, you can use dynamic. And let's call it B. Let's give it a name. I am a string. So right now, B is a string and it contains the value I am a string. Now let's go ahead and change B to an integer. Now B holds the value 4. So console.writeLine means that I can perform some operations with B. So I can add 3 to it, so that it becomes a 7. So as we see here, this means that B at line 21 was a string, but then at line 23 it changed its data type and became an integer. So how is that? It's using the dynamic keyword. So dynamic versus var. Dynamic allows the changing of a certain data type to another data type within the program, and var implicitly infers the data type of a certain variable, and then it is not allowed to be changed throughout the program. In other words, we say that the dynamic data type is defined at runtime, whereas the var data type is defined only when compiled, and then it cannot be mutuated. So that's it for all data types. Let me erase everything right here and let's start doing some math. Now there might be one data type I didn't mention, which is the Boolean, because I always associate bools with conditionals, which we will be discussing later on in this tutorial, but let's briefly discuss it here because it's really a basic data type. So bool is a Boolean. It only takes two values, which is either true or false. So let's say I have a Boolean which is called can swim, which is equal to true, not try, true as such. So if you want to go ahead and just print it out, it will print out true as such. Now the other value it could take is false. It cannot take any other value. So that's it for all data types. Let's start doing some math. So for this, I'm going to use only the console.write line and just display some certain operations. And the operations that we can do is, let's start with adding two simple integers. 6 plus 3 is equal to, as you can see here, I'm concatenating two strings. First string is 6 plus 3 is equal to, that's the first string, and the second one is going to be automatically casted towards a string. So 6 plus 3 right here is an integer, 6 plus 3 is 9, and the 9 is going to be automatically casted to be a string. So run, and there you have it, it's a 9. Now we have three more elementary operations that could be done, which is subtraction, multiplication, and division. So minus, times, and divide. So the way you do that is using the minus sign, the asterisk sign to perform multiplication, and the / to perform division. So running that, there we have it. 6 times 3 is 18, and 6 divided by 3 is 2. Now what problems can we have here? Let's say I want to divide 6 by 4, not by 3, run, and as you can see here, 6 divided by 4 is not 1, it's 1 point something. But since 6 and 4 are, integers, any operation done on two integers should be an integer. You might be interested in the, the integer part only. If that's the case, then you're good to go. And if that's not the case, well, you're going to have to do some casting. So let's cast both 6 and 4 to doubles. The casting is done as such. As you can see, 6 divided by 4 is 1.5, which is true. Now, what just happened here? We casted 6 to be a double. Now, 6 now here is not an integer anymore, it's a double. Casting is just a way of, transforming a certain data type to another. So let's try dividing a double by an integer, and the output is going to be the dominant data type, which is a double. Good, so it's enough to only cast one data type. Now, can we cast the output? Let's check. You cannot, because the output is 1, and casting 1 to be a double is also 1. So the decimal part, if you will, of your output is lost. Now let me copy paste this, place it right here, and let's talk about the modulo, or in other words, the remainder of division. So the remainder here is 0. Dividing 6 by 3 does not leave any remainder. So let's try dividing 6 by 5. We know that we have a remainder which is, and there we have it. The remainder is 1. So those are the basic operations you can do. You've also got other types of operations. Let's define an integer which is 1. Let's see what the following does. So I++. So I++, so what does I++ do? So I++ is a way of incrementing a variable. I++ is the equivalent of I plus 1. So instead of having a value I, you would have a value I plus 1. But it's not working, and why is that? Well, it's because the incrementation is not going to happen at line 13, Instead, it's going to happen at line 14. This means that you're going to print the value of I, then increment. So to demonstrate this, all we have to do is just print the value of I just right here. So running that, you can see that the value of I is now 2, all thanks to line 13. The effect of the incrementation happens at line 14. So in other words, print I, then increment. So running this, I++ is 1, now I is 2. On the other hand, if you would want the incrementation to happen at the same line, you would want to use ++I. So if you use ++I, the value of I at line 14 is 2, right? So ++I would increment then print as follows. So as you can see, since the value of I is 2, incrementing I would be 3, and then we print it, we have 3. And similarly, the decrement operation, let me just emphasize here, the value of I is 3. Then let's print the value of I, just copy paste it from here, and you also could decrement then print as such. So run. Line 17, as you can see here, is here. So here we're printing the value of I. Then at line 18, it is decremented back to 2. Then at line 19, you decrement, then you print 1. That's when you place the minus before the I. So those are really the basic operations within C#. And that's it for the basic math. Now let's do some more advanced math. Let's say I have a double, which is x, and it is 5.3. So let's start printing on the console some trigonometric functions. So maybe the cosine of x. The way to compute the cosine is using package math.cosine of x. Let's print it out, and it is this number right here. Now let's give something like 3.14, which is almost pi, and print the cosine of pi, which is almost -1. Now let's say you want the exact value of pi. I think you extract it as such. This is how you do it. So the cosine of x in that case is -1. You've got other functions such as the sine and the tangent, and you can extract them as such, print it out, and there you have it. You've also got hyperbolic trigonometric functions. All you have to do is add the h right here, and right here. So you'd have the hyperbolic cosine, sine, and tangent. Perfect. That's it. Right, so let's do something else. I don't know, maybe you're interested in the absolute value of x. The way you do it is using the abs of x. Since x is positive, it's just going to print it out as such. But what if x is negative? You're going to get the positive part. Okay, so this is the abs function. We've also got, let's say I have another double, x plus 2. We've got other types of mathematical functions, which is the minimum of two numbers. The way you do that is using the min of x and y. Run. There you have it. The minimum is x, which is pi, and the maximum is indeed y. Okay, now the square root of x is, you can do that using the square root function, sqrt. Run, and this is the square root of x. Let's say you're interested not in the square root, but in power of x. You would like to raise x to the power 2. The way you do that is math.pow, which stands for power, and x to the power 2, which is 9.867, almost. You've also got rounding functions such as the floor of x, math.floor of x, and you've also got the CO. So running that, you're going to get something like 3 and 4. So the smallest integer closer to x and the largest integer closer to x. Those are really the most common used mathematical functions in C#. You've got way more functions. Let's use the auto-completion feature right here. Got all those functions right here, which you can read about. You've got a log function, log to the base 10. All those are valid functions within C#. You can also use the sine function. It returns the sign of number x. So if x is positive, you're going to get a 1. If x is negative, you're going to get something like -1. And if x is 0, it's a 0. So this function is a 3-valued output. Perfect. So that's it for math. Let's talk about statements that evaluate to either true or false. Let me define the boolean. Let's check if a certain value, int x, given as 6, let's check if this value is between two numbers, 1 and 10. First of all, is it greater than 1? So x greater than 1 is a statement. It's either true or false. In our case, statement is going to be true. If I go ahead and print this out without having to store it in a variable, if I just want to automatically print it out, I can do right because x is 6. If I go ahead and change its value to -5, I run it, I should be able to see false. Now let's say I'm interested in more composite statements. If you want to check if x is between 1 and 10, well, the following is not allowed. This is not valid in C#. Well, all you have to do is take this statement and perform a certain AND operation using double AND right here. So x greater than 1 and x less than 10. Is this the case? If yes, print true, else print false. So both of them should be true so that the final statement is evaluated to true. In our case, it's true. If it's either greater than 10, if one statement is false, then the entire statement is false. X is indeed greater than 1, our statement is false. On the other hand, if I use the OR operator using two pipelines as such, if I use the OR operator, it suffices that one statement of the following composite statements is true so that we say the entire statement is true. In our case, x greater than 1 or x less than 10. The following is true if x is 11. So running, it is true. Now you also have greater than or equal, so this means that 1 is inclusive, not exclusive. So 1 will evaluate to true instead of false. As such, you can use it for greater than or less than as well. Means I can put it here. You've also got statements where you could test for equality as such, double equal instead of one equal. So right here, this is a statement where we are testing if x is equal to 1 or not. In our case, it is equal to 1, therefore we should see it true. Now if we go ahead and change this value to another value, let's say -1, we should be able to see false. Now you also have the not operator. So not is an exclamation mark as such. So not true, it's false. So it's the negation of the Boolean variable, and not false is true. Okay, so this means that if you want to test for the opposite of a certain statement, you can just go ahead and insert the exclamation mark right here. So running that, we should be able to see false. Because x is 1, this statement is true, and therefore the negation of this statement is false. Now we're done with Boolean statements. Let's talk about conditionals. Now what conditionals are, just blocks of code which execute if a certain Boolean statement is true. So to demonstrate this, let's say I have a Boolean A which is true. If A, do the following, else do the following. So this block of code right here will execute if A is true, everything here will be executed. And I'll just copy paste this here and just say if A is false, everything here will be executed. So that being said, either this block of code will be executed or this block of code will be executed. They cannot be executed at the same time or one after the other. So let's try to print something here. Console.writeLine. A is true. And I'll just copy paste this here and print A is false when it's false. So run, A is true. We are in this block of code. Another way of saying line 15 is instead of if A, you could just equate it to true. Now let's say you would like to test if A is, I don't know, 1. You get an error saying that operator double equal sign cannot be applied to operands of type bool and int because A is a boolean. You cannot compare it with an integer. Now let's see if A is false. Is this statement true? Well, no, it's not, because true is not false. So here let's change the printing and say A is false. Here A is not false. Run, A is not false. So this block of code is being executed. Since this statement has been evaluated to false, the else block code will be executed. Perfect. So that's it for conditionals. This is the basic explanation of conditionals. You can really go even deeper with that. You can have nesting here. You can say if, so let's define a b here, which is 20. If b is less than 15, else we'll copy paste this, b is greater than 15. Let's here put less than or equal to. So here we will have is strictly greater than 15. So what does that mean? It means that this block of code right here, this test right here, will be executed if A is not false, right? So A is true, therefore this test will be executed. Let's give it a shot. B is strictly greater than 15. Now let me just change A to false. Means all this blocks of code will be discarded because this block of code will be executed only. So let's run this, and as you can see, only line 19 was executed, which is saying that A is false. Perfect. You can also have composite statements right here. If A is equal to false and B is equal to 20, for example, this all should evaluate to true, and so on. So other than that, you've got something called ternary. So that's a shorthand of an if-else statement. Let's say you have a boolean which is can swim, and let's say you have if the age is, let's say int age is 4, and you have a criterion saying, oh, if my age is greater than 10 with a question mark, then true, otherwise it's false. So I'll just go ahead and print that here, can swim. So what does that mean? It means that if the age is greater than 10, so this is the statement, then can swim is true, otherwise it is false. So running that, we're going to get a false because 4 is not greater than 10. If I change that to 40, then I should be able to see true. Good. That being said, you would like to have can swim as a string. Those two values right here should be strings. So let's say yes and no. So can swim will take on the value yes if age is greater than 10, otherwise it will take the value no. So running that, since 40 is greater than 10, then I should be able to see yes, otherwise I have, let's say 10, it's less than 10, so false. It's not strictly greater than 10, so it's a no. Now this is, as you noticed, it's shorthand of the following code. So instead of me going ahead and writing the following code, you can just use this simple line of code. Okay? This is the equivalent of this. Perfect. Okay, now let's do some loops. So what is looping? Looping is a way to execute the same block of code multiple times. So let me show you what I mean. Let's say I've got an integer k, which is 0, and I would like to keep incrementing k till it hits a certain value. Well, this could be achieved using looping. So one way of looping is using the do-while loop, which is basically as follows. So do, then while. So what does that mean? Simply means that you keep doing this block of code right here while the statement is true. We want k to hit 10, right? While k is not equal to 10, keep incrementing k plus. And just for the record, let's print out k to see where we are. K is equal to the value of k. So you keep incrementing k until it hits 10. When it hits 10, the following statement is now false and the loop will stop. So let's run this, and there you have it. So k is equal to 0 in the beginning. It enters this do loop. There is one thing worth mentioning, which is the condition is being tested after the first entry of the do block. So in other words, the following will run at least once. So let me show you what I mean. Let me put 10 right here. Is not equal to 10. Well, when k is equal to 10 means this is false, right? But regardless, this block of code is being executed. Run, and there you have it. It's continuously being executed because when k is 10, we enter the following block of code, we print the value of k, then we increment k to be 11. Once we're here, 11 is not 10, it's true. And you will keep adding k forever because you will never hit 10. So let me stop this. Now, if you put 9, it will execute once. There you have it. K is equal to 9, increment k to 10. So now k is 10, the following statement is false, we exit the block of code. Now, let's say you're interested in first testing the condition before running the block of code. So you can do this using a while loop. So the while loop is as follows. The statement goes here. So while k is not equal to 10, do the following. So I'll just copy paste the same block of code right here and just focus here. So now k is, let's go back to the 10 example, k is equal to 10 example. And right here, we're not going to run an infinite loop because once the compiler reaches line 24, it will first test if k is 10 or not. So 10 not equal to 10 is false, and therefore this will never be executed. So running that, we see nothing, which means that this block of code has been skipped. Now if you put 9, you run it, you will only see k is equal to 9, as before. So you'd want to use a while loop when you care about testing for the first time. You'd want to use a do while loop regardless when you want the block of code to run at least once. So run the block of code, then test the value of k. A while loop will test the value of k, then run the block of code. They sound similar, but it's totally different, logically speaking. So one last loop is the for loop. So the for loop has the following blueprint: for int I is equal to 0, I less than 10, I plus plus. This is the simplest example. So that means that you first initialize an I to be 0, then at each iteration you would check the following condition. Is I less than 10? If yes, then run the following block of code. So each time you run, you would increment I. So to check this, let's check the value of I, run, and there you have it. So I is equal to 0, it's less than 10, I is 0. Then when you reach back to line 32, right here, you would increment I, then do the same thing. Is 1 now less than 10? Yes. Enter the following block of code until this condition is no longer satisfied, or when it's evaluated to false. The last case is when I is 10. If I go ahead and check the value of I at line 37, it will be 10. Now, why is it giving me an error here? Because I have defined my integer in the while loop. You can do it alternatively as such. If you care about keeping the value of I, you define it here and initialize it here. So running that, and there we have it. I is 10. And I is 10 due to line 38. If you care about the edge value, which is 10, you can go ahead and say less than or equal to 10. So when it's 11, the loop will stop running. So now let's talk about strings. Using the keyword string, you can define a string. Let's call it sentence. And today is a good day. So as you can see, a string is nothing other than a concatenation of characters. So the way you print a string is the same way you print any other variable, as follows, as you can see right here. You've got a lot of functionalities you can do with a string, right? They all come embedded with the string class. As you can see here, let's test some of them. So let's say I want to test if a string is empty. So string dot is null or empty sentence as such. So run false, it's not empty. And let's make it empty. So an empty string would look like this, right? Run, and it's true, okay? Now you've also got the is null or white space, run, true because it's null. Now let me put back the sentence here, run, false. Now white space, you can test if there's only a white space, so it will return a true. How about two white spaces, run, it's a true. So white spaces are accounting in this function as empty or null. You could also extract the length of your string. So sentence.length as such, it's 2 because we have 2 white spaces. Now let's put something more meaningful inside, like this is a good day, this is a good day. Right? So we've got 18 characters in our sentence. Let's say you would like to grab a certain character at index 0, for example. So at index 0 is the first letter, which is uppercase T. The one at index 1 is lowercase h, right? And so on. You could grab them using this notation right here, using brackets. Now let's say you would like to get the index of the word this. The way you do it is using sentence dot index of and followed by the substring this. which is case sensitive, and run, you should be able to see 0. Now let's find the index of the word good. It's at index 10. So 0, 1, 9, and a 10. Okay, one last thing. Let's check the word is. Run. It's at 2, so 0, 1, 2. The function index of will return the index of the first occurrence of the inputted word. So as you can see, we have two is right here. This is the first one, this is the second one right here. So this function will only return the index of the first occurrence. Now let's say I have another string another sentence, right? This is a bad day. And I would like to test if sentence and another sentence are equal. So equal in terms of they contain exactly the same sentence, okay? So the way to do this in C# is using the equals method. So sentence dot equals another sentence as such. So run, and it's a false because they're not equal. So let's say I would change good to bad as such and run. It's true because they're exactly the same. Let me return it back as it was. So let's say now you would like to trim your sentence. Say it looks something like this. You have white spaces in the beginning and you would like to get rid of them. Well, all you have to do is just call the trimming function, trim, as such. So run, and there you go. Let's say you'd like to replace the word good with the word bad. Well, you can do so using the replace function, and the old substring goes here. So the word good, replace it with the word bad. So let me just call another sentence, call it modified sentence, and just print the modified sentence. So run, and there you have it. Let's say you would like to delete some characters or a substring in your string. You can do that using remove. So remove takes in a starting index. So say 4, run. So as you can see, the remove deletes everything from the 4th index till the end. Okay, let's talk about special characters. So special characters are characters that have a special rule. So let me show you what I mean. Let's say you would like to create a paragraph containing sentence 1 and 2, but sentence 2 is on another sentence. Right, so let me show you what I mean. Sentence 1 plus sentence 2. Now, as we said, plus stands for string concatenation. And if I go ahead and print paragraph, I will get both sentence 1 and sentence 2 are on the same line. And that's not what I really need. I need each on a separate line. So a proper way of doing that is to insert some sort of special character right after the full stop here. So in other words, between sentence 1 and sentence 2. So there should be a special character right here to skip a line. It turns out that this special character is the \n. So if I do so, I'd end up with sentence 2 being on the second line and sentence 1 on the first line. Now you've also got a \t, which stands for tabulation, which is an amount of white spaces. I think it stands for 3 white spaces. You've also got the double quotation. So double quotation, if you want to insert it in a string, you should mention a \ before it, because double quotation in C# is reserved for strings. Therefore, a \ double quotation is understood as a double quote character. You also have the single quote as such. There you go. And you've got the \ itself. So \ twice corresponds to \ right here. And that's basically it. So what is a string builder? A string builder is simply a mutable string, which means that it allows its content to be changed. When you create a string, what's going on behind the scenes is that you actually create another twin string in memory. Now there's a lot of complicated stuff to this. It's not as simple as it sounds, but it's good to know that allocating memory for a string is exhaustive because you're creating another copy of it, On the other hand, string builders do not suffer from this issue. So once I go ahead and define a string builder as follows, string builder is a new string builder as such. You do not create another one in memory. So a string builder is normally used when you want to be able to change or mutate the content of the string. This is more practically efficient. So this is the way you define a string builder. You can go ahead and print it as follows. It's empty because we didn't insert any content to it. So if you want to append to a string builder, all you have to do is call the append function. Since it's empty right now, appending means inserting content to the string builder. So let's say I want to insert this is a string builder as such, and let's go ahead and print it. So there you have the content of the string builder. Now what's good about the string builder is you could append in a format type of way. So in other words, at this point the string builder is empty. So if you call the append format function, you can go ahead and do something like this. My dog's name is 0 with curly brackets as such. Curly bracket 0 indicates a first argument, and he likes to eat, let's say, 1. So as follows, you create a string builder where 0 and 1 could be changed to your own good. So how do you pass 0 and 1? Simply using the next arguments. So as you can see here, so my dog's name is, let's say, Romeo, and he likes to eat bananas, okay? So let's print that out, run, and there you have it. You could also go ahead and clear the contents of a string builder simply by calling the clear function. Print to make sure. There you have it. It's empty. It's right here, by the way. You could also remove content. So let's say I would like to remove the word name from this sentence. All I have to do is call the string builder dot remove, and it has 2 arguments. So the start index, so n is at index 0, 1, 2, 9. So the first argument should be 9. And the second one is, you know, the length of the content you would like to remove. So it's 4 or 5 with the white space. Now let's print it. So let me remove this before, because at this point the string is empty. The string builder is empty. And run. So there you have that. The name is gone because it has been removed. You can also get the length of your string builder using only the length property. It's a property, it's not a function, because we did not end it like this. It's a property of the string builder class. So it's 45. You can also replace content within your string builder as such. So replace, let's say I would like to replace each occurrence of O with an I, right? So O with I. It's as simple as that. Let's print the content. As you can see, this sentence that it doesn't make sense. So the most important part here is that each O occurrence has been replaced with an I. And you can also, you know, you could cast it to another string. So let's say you have a string instance in your program. So my string, and you would like to cast or transform the string builder to a string. So all you have to do is call toString as such. So you can now treat my string as a string. Okay, arrays. An array is nothing other than a collection of data. Could be integers, floats, doubles, characters, whatever you want. And the way you define it in C# is as you define a integer as such. So let's say I want an array of integers. And the way you define it is as follows. So instead of saying int x, you'd say int brackets x. And the bracket is basically saying, oh, x is an array. So I might as well name it my array as such. So this is how you define an array in C#. In this case, it's an empty array. And let's say you would like to declare an array some size. So the way you do that is equating it to a new int array as such. So let's say you want an int array of size 10. This is how you declare it. At this point of code, it's empty, so you could fill it up or not. But the way you fill it up is as follows. So let's do that using a loop. For of I is, let's fill it up with multiples of 10. So I times 10 as follows. Run it to make sure everything is working, so no error. Okay. And now let's see what happens if I just console write line. So I just print it out as follows. Will it print it out? It just tells you, oh no, you only have an array, so you have to print it out element by element. So to do that, let's create another for loop. Int I is 0, I less than 10, I plus plus. You could also print it inside here, but let's just pretend that we don't know what's inside, and the goal is to, you know, print out the array, right? So my array I as follows. Let me remove this and run. And there you have all the elements inside. You could also fill the array upon definition. So what I mean is the following. Instead of filling it up using a for loop. You could define it upon instantiation, so 1, 2, 3, 4, 5 as follows. And let's say I don't know the size of my array, so my array dot length would return the length of your array, which is in your case 5. Now run it, and there you have the elements inside your array. You can go ahead and change the elements right here. There you have it. Now, as we said, the length of the array is obtained by indexing the length property. So if you want to, I don't know, print it, you could say my array.length run. There you have the length. Let's be more organized and just type a message here saying the length of my array is equal to plus, concatenation. We're concatenating the length to the sentence, and there you have it. Let's add some elements right here. 100 minus 10, run. Should give us 7 now. Yep. And here we could see the elements here. You could also insert in the for loop some useful message saying element number is equal to, and which number? It's I. Okay, and let's start by 1, right? It's more readable. So I'll insert a parenthesis right here, and it's an I plus 1. Run, and this looks better, right? So there's the first element, second element, and so on. And we have 7 elements, okay? This is how you read from an array. Let's say I want to change the second element over here. Well, you could just do this. It's sitting at index 1, so we're counting from 0. And I don't want it to be 20, I want it to be, I don't know, 120. Run, there we have it, right? And what happens if I index an element which doesn't exist? So something at index 9, and fill it up to 10, you would get an error saying system.index out of range exception. So you cannot fill up an array with more than its own capacity, right? So let me remove this, run it again, there's no error. Good. You could also, instead of grabbing the elements as such using my array index I, you could, let me comment this out, and let's do something in another way. So using the for each loop. So for each loop in element in your array, my array. So in this case, instead of saying my array I, you could just grab it using the element. So I'll just copy paste all this right here and put the element right here. And as you can see, there's no more I, right? So let's say you have an int right here, initialize it to 0, right? And at each loop, you would increment this I, right? So run, and you have the same output. Okay, let's say you would like to find the index of a certain element, let's say 50. How would you go upon doing that? You could use array.indexOf, right? So index of, first argument is your array, which is my array, and the second element is the value, so 50. This should return 0, 1, 2, 3, a 4, because this is sitting at index 4. So running that, and there we have it. Let me just comment everything out, just because we explained this. So run, and there you have a 4, right? And let's say you're trying to read an element that doesn't exist, so 51. It should return a -1, right? So -1 means the element does not exist. So that being said, you could write an if-else statement, so saying if-else, if array, index of my array, a certain element, right, is -1, then print element does not exist, else, right line, element is sitting at index, and you could just run it again. It's not the best way of doing it, but it's one way of doing it. So int element, and let's say the element is 100, and it's sitting right here, so it's at index 5, right? There you have it, index 5, and why do we have a -1 here? It's coming from this line right here. So let me remove it. Actually, let me delete all this. Now let's run again. Element is sitting at 5. Now let's search for 101, which does not exist, and element does not exist, right? Those are the basics of arrays. This is a one-dimensional array. All what has been said applies to one-dimensional arrays. You could also extend this notion of arrays to two-dimensional arrays. So the way you define a two-dimensional array is as follows. Int, instead of, one bracket, you put a comma saying this is a two-dimensional array. So my 2D array is, so let's define it. You could define it as such. And let's say I want a 3 by 6 array. Now the way you fill up the array is as simple as before. So instead of running one for loop, you'd have to run two for loops. So the first dimension, you could see it as the number of rows, and the second one is the number of columns. So looping over the rows and columns as such. First loop, let me insert a comment here saying loop for row, and the second loop is a loop on the columns. So j less than 6, j++, and inserting a comment here, loop for column. Now let's fill it out. The first index is the row index, and the second index is the column index, and let's insert something like I don't know, plus j, right? So we're inserting in the array the row index plus the column index. So at this point of the code right here, we filled up the array, and now let's pretend that we didn't loop over the array just to print it. So print my 2D array as we did before. For int I is 0, I less than 3, and I++, and for j is 0, j less than 6, and j++. And now let's let's say write, because I want to print all the elements in one row on the same line. So my 2D array, ij, and I'd like a comma in between each element. And when I'm done with the row, I want to go to a new line as such. Now let me run this. And there you have your array. Now there's a comma here which doesn't look nice. Let me remove it. So here, if j is strictly less than 5, you insert this, else you just print it without the comma, right, as such. So run, and there you have it. So at this line, I is 0, and at this column, j is 0, j is 1, 2, and so on. So as we can see, this is indeed I plus j, right? You could also fill in the array upon instantiation. So instead of saying 3 by 6, I could go ahead and insert curly brackets as such, and let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. So let's pretend I don't know the number of rows and columns. Well, you can read that using my 2D array dot get length, and 0 means row. So here we have two dimensions, so I have another length, which is get length 1, as follows. So this is the number of rows, and this is the number of columns. And let me do a small modification here, when this is the number of columns minus 1. So let's run it, and there you have it. Okay. So now let's talk about lists. So unlike an array, a list could have a variable size. So let me show you what I mean. So the way you define it on C# is using list and specifying the types of the data inside the list. So let's say I want a list of integers, right? And let's call the list L equals to new list int. And now I have an error here. It's because we need to include the namespace. So this is like a package that supports lists. It's using system.collections.generic. So the list object is found within this namespace. And now all I have to do is just call l.add. And what add does is that it just adds the value to the list. So let's say I first add the value 6, then another value which is 12, then a 20. Let's print the total number of elements inside L. So l.count, run, and we have 3 elements. If I add one more, I'll be able to see 4, right? Now let's say you're interested in printing the number of elements. All you have to do is use a for each. So for each int element in L, print my element. So running that, I'll be able to see the elements. Now let's say you have a certain list or array that you would like to stack next to your existing list. So let's say I have an array as such. Int array is, let's say, 100, 200, and 300. And you would like to stack array next to L. So all you have to do is call your addRange function and pass it the array. So run, and there you have the elements being stacked on the bottom of the list. You can also clear your list as easy as that. So your list now is empty. And you can also declare a list using an array. So let me get rid of this and all this. So using this definition right here, I will paste it here. And let's say you don't want an empty list at initialization. You want the values of this list to contain the same values as the array. All you have to do is pass it the array as follows. And now let's print it. And there you have the elements, okay? You can also, by the way, do this. So I can copy paste all this right here, right? So I'm defining an array at initialization, new. All I have to do is say new. So run, and there you go. So at this moment right here, I have a list that contains the values 100, 200, 300. Well, how can I extract a certain element of a list? It's as simple as extracting elements from an array, reading elements from an array. So L2, run, I get 300. The one sitting at index 2. 0, I get the one sitting at index 0, right? Let's say I pass it 5, which doesn't exist. I'll get an error saying unhandled exception. So argument out of range exception. So now let's say I'm interested in removing a certain element. Well, all I have to do is run the following l.remove. What it will remove right here is the value, not the index, not using the index. You specify a certain value and this value would be removed. So let's say I want to remove the value 200, right? So after line 18 is executed, my list should contain only the values 100 and 300. So let's print the list and run, and there you have it. Now, on the other hand, let's say you would like to remove a certain value that is sitting at a certain index. So the same thing, I want to remove 200, but not by passing the value. I know that 200 is sitting at index 1, and I would like to remove it knowing this piece of information. So you can use remove at index 1, and you should be able to see the same results. On the other hand, let's say you would like to insert a certain element at a given index. So you could go ahead and use insert as follows. Now, this function right here takes into account two parameters. The first one is the index, and the second one is the value or the item you would like to add. So let's say I would like to add at index 3, which is currently empty, a value of 400. So running that, I can see it right here. What happens if I add it to the fourth index instead of the third? The third is empty, right? Because currently I have 3 elements. So from 0 till 2, hence the third element is empty. So if I go ahead and insert at the fourth element, what happens is that I get an error saying argument out of range again. So you have to make sure that this index is within your range. An example would be 1, run. And as you can see, 400 now is sitting at index 1. It's squeezed between 100 and 200. So it sits right here. And 200 is shifted to index 2 and 300 is shifted to index 3. Now, let's say you're interested in returning the index of a certain value, so 300. You know that your list has a value of 300 and you would like to return its index. So console.writeLine, the index of value 300 is, so l.index of is the function you would want to use for this, and run. So as you can see, the index of value 300 is 2, right? Let's say 200 is at index 1, and let's say I pass it a value that does not exist. You will see an index of -1, meaning that it doesn't exist. On the other hand, you can check if a value exists or not using the contains function. So a contain returns a boolean, a true or false, telling you if a certain value exists or not. So console.writeLine exists, else it does not exist. So let's run that, and 200 does exist indeed, but 250, for example, does not exist. Now let me get rid of this, and let's say you have here 1,000 instead of 100, and you would like your list to be sorted in, let's say, increasing order. You don't want 1,000 to be at index 0, you want it to be at index 2, because this is how it would be in case your list L is in increasing order. So all you have to do is call the sort function of the list and run. As you can see, 1,000 is sitting at index 2 instead of 0. So this list is in increasing order. Let's give a random list right here. So I'll just input random numbers and run. And as you can see, your numbers are listed or sorted in increasing order. And that's almost it for lists. Right, so now let's talk about exception handling. So what exactly is exception handling? Well, it's a type of way to, in case you have any type of error, you would like to do something else when you have this type of error, then you'd want to use exception handling. And really, exception handling is just a try some code, and in case you have a certain error, you can just catch it. So this is also called a try-catch block. So like if-else block, you've got a try and a catch block. So let's do some stuff right here. Let's say I would like to declare an integer x and just print it on the screen without any error, right? The value of x is just x, right? You'd want to catch an exception. So what happens in C# is that when you have an error, it's thrown as an exception object. So exception EX, for example, and EX is the name of your exception or error. And in case you saw in this lecture, every time we ran through an error, we saw somewhere that it has an exception at the end of the type of the error. So let's say I had an array of size 5 and I exceeded the size of the array, then the exception is of type out of range exception, something like that. So pretty informative. It tells you what type of error you have. So right now, if I execute this block of code, there shouldn't be any error. Let me just throw a message. Oops, you have an error, right? So running that all seems pretty good, right? So let's commit a certain error. So one type of error I could think of is dividing by 0, for example. So let's say grab your integer, right? And then you divide by 0. Let's run that. And there you have an error. As you can see, the C# program did not stop executing. No, it sensed by itself that there is an error at line 16, so it will jump to the catch block. Let's be more specific if you want. So your error is the following, right? So the way you can print your error type is using ex.message, right? So running that, this is what we get printed on the screen. It's the following message: attempted to divide by 0. So here really C# is trying to be informative using the message property of your exception. It really tells you what type of error you're having. So it's attempted to divide by 0. You can also get the name of your exception. So get type dot name. So run. And as you can see right here, this is the name of the exception. It's a divide by 0 exception. So going back to what I was saying before, the array example. So let's say I declare an array, which is array, and it's equal to 1, 2, 3, and 4, right? So this is an array of size 4. So what happens if I go ahead and access the 5th element, which is sitting at index 4, and I want to fill it up with 5? What should I get here? Oh, so I have a divide by 0 exception. I should remove this line and the one on top of it. So let's say I have this block of code right here. So running that, and there you have it. It's an index out of range exception. This is the type of error we were getting previously when we tried to access an index that we cannot access due to the array size. It's static size. Let's be more informative. Let's see what the message property is telling us in case of an out of range exception. So index was outside the bounds of the array. C# is being more expressive. It's telling us what's going on, okay? Okay, so now let's talk about enums. So what enums are, they're just unique types with some names and some values. So what that means is that it's a variable like an integer, like a string, and so on, where you define the range of values of that data type, to be more specific. Now, the way you define an enum is as follows. So public, let's say, or in case you don't want it to be public, you can just go ahead and type enum. And this goes outside the scope of your program, right? And after enum, you define the name of your enum. So let's say you have an enum of name car. And car Or let's be more specific, car model, and car model only takes on, let's say, some values. So examples are BMW, Mercedes, and I'm not paid to advertise for those guys, right? So BMW, Mercedes, Ferrari, and let's say, I don't know, Rover, right? Okay, so this is how you define an enum. So the way you declare it in your scope, the program is as follows: car model, like int. So your int is the car model, if you will. And then the name of your enum, the name of the variable. So let's say a car is equal to, now, if you do this, it's the equivalent of saying something like int x. That being said, car is now undeclared. So if you go ahead and just, print it, you will get use of unassigned local variable. So this variable is not declared, so you have to go ahead and declare it. So car model dot, and then you access the values as such. Let's say it's a rover, so run, and you get the type rover. So this is really useful when you just have, instead of, I could have, declared car model as a string and then said, okay, so string car is rover, and that's it, right? This is not really useful. It's not being informative. It's not telling you that your car could actually only take 4 values because you declared it as a string. So the enums, you're being more explicit. You're saying that your car could only take 4 values, or I don't know, 5 values, Volkswagen maybe, or whatsoever, right? So to demonstrate the usefulness of enums, you can just go ahead and simply test for the values. So if car is equal to car model dot rover, then just go ahead and print out, I just bought a rover. You can do the same thing for the others, right? So we'll have 5 if statements here. You can also use a switch block. I'll just change the values right here. So VV. So running that code, we get I just bought a rover. Changing the value right here to VV and running again, I just bought a VV. So comparison really is much simpler. Instead of using some built-in function for strings, you can just use this simple comparison. And this is actually faster than comparing strings, because with strings, you'd have to pass by each character by character. That's what happens behind the hood. So when you're comparing to strings, it starts character by character comparing. So this might take n operations, right? So let's say you have a string of size 100 and another one that is being compared to, which is also of size 100, and the first 70 characters are the same, with the only difference being in the 71st character, for sake of argument. So what's going to go on here is that you're going to take 70 operations to come up with the conclusion that those two strings are not equal. That's in case we're using a car model of type string. Well, if you're using an enum, it's just one operation, because behind the scenes, what's going on here is that BMW is not actually stored as a BMW. No, it's stored as a certain number, right? So there's a certain key corresponding to Mercedes, and C# would then compare those keys instead, which is only maybe 1 or 2, digits, depending how many car models you have inside your enum. So that's basically it. That's the usefulness of enums. Okay, let's talk about methods. So what methods or functions are is just a block of code that gets executed and accepts some inputs and possibly returns some outputs. So a typical method, how it looks like, is the following. So let's say your method doesn't return anything but does some stuff. Void means it doesn't return anything. And after that, after specifying the return type, which is nothing in our case, you specify the name of the function. So let's say your function returns the sum of 3 integers, possibly. So sum of 3. And after that comes your inputs. So int A, B, and C. They could be of different types. We can have like a string right here saying name, for example, if you want to do something with a 4th input. But in our case, we don't want to do anything with a 4th input. All we have to do is return a sum of 3 inputs. And because I want to return sum of 3, my return type should be an int instead of a void. So int sum of 3, I should return is the keyword, and it return A plus B plus C. So to test your function, let's print on the console, I don't know, 3 plus 4 plus 5 is equal to, let's call the function right here, and let's input the integers 3, 4, and 5 as follows. So we run right now, and we could see the output right here. Now let's say your function belongs somewhere outside the scope of your main, which is most probably inside a class or a struct, as we will see later on. So for sake of discussion, let's put it right here, and you will see an error right here. And what is the error? It is telling you that an object reference is required for the non-static field, which means that your function should be static. And we'll see later on what static means in terms of classes. But right now, know that static keyword exists, and it basically means that your function doesn't need an instance of the class program to be called. All you have to do is just call the function as it is. Or in case this method belongs in another file, in another class, you will have to call program.sum of 3, because sum of 3 is inside program, right? 3, 4, and 5. So this is how you refer to methods when they belong to different classes. But since you're here in the same class, so I might as well remove program, and all is good, right? So now let's say your function doesn't return anything, it just does some stuff. So I'll go down here, static void. Void means it doesn't return anything. Let's say your function would print some info. So you pass it a name, an ID, and I don't know, an int, which is balance. Let's say you're at a bank and you would like to see some info related to a certain client with a certain name that has a certain ID, and his balance is, I don't know, you get it somewhere else. Let's say it's an input right now to the function for sake of discussion. So all this function does is it prints. So print name with ID has, let's say the currency is dollars. This is my function, as simple as that, and the way I call it is just by its name. And now I'd have to pass, the arguments. So the first argument, let's say John. Second argument is an ID, and why is it a string? Because I put it that way. So let's pass a string, something random like this, with some numbers and some special characters possibly, and a balance of this, right? So run, name with this ID has that much dollars. Okay, let's talk about something which is really interesting, and it's called method overloading. So that sounds really fancy. It's as simple as that. So I'll just copy paste this block of code right here, and as you can see, it's yelling at me. There is an error, and the error is that, oh, you have two functions with the same name. That's not allowed in C#. Well, it's allowed in one case, which is when you have, let's say, the parameters are different. So here I have 3 parameters, whereas here I have 2 parameters, right? And in that case, it's allowed to have the same method or function name. Well, that is method overloading. How does my main know which method to execute? It depends on the number of parameters I give it. If I give it different parameters, if I give it 2 parameters as such, it will call this function. Whereas if I give it 3, it will call that function. So let's give it a try, and as you can see here, I have an error because ID doesn't exist anymore. So I'll just remove the ID. So all I have to do is name has that much dollars. So I'll call now the second function right here. And as you can see, it's the second method that has been executed, not the first one. This is a feature called method overloading. Now let's say I have the same function again, but with 2 inputs, but different input types. Okay, so let's pass the balance as a string right now instead of an int. As you can see, I don't have any error. Let me just print a console.write line saying in which method I am. I am in method 2 right here, right? This is the second one, and up here it's the first one, and down here it's the third one. So right here I have 2 arguments, means that I am either in the second or third. Now since the second argument is an int, I will be in the second, as you can see right here. Whereas if I just change this to a string as such, I will go down to the third, okay? So not only it depends on the number of inputs, no, it also depends on the input type. That's method overloading. Let me also show you one more thing. Let me copy paste this. So it's the same exact as method 3. But let me put method 4 right here. There's still an error because it's the same signature. So this is called a method signature. It's how you define your method. So I'm just going to change the output type to an int and possibly return something like random, like let's say this. Is it going to be accepted? Well, no, it's not, because it only depends on the parameters. It only depends on the input types. Once you have the same input types, C# is going to get lost and tell you, hey, you have the same method implemented twice. What's going on? So you should at least change one parameter. So let's input something here. I don't care. Something like that. Well, that would work, okay, but it doesn't make any sense. You can also choose not to input anything. Return this to a void and say just I'm in method 4. Right now I'm not calling it because I'm passing it some parameters. Let me not pass it anything. Now I'm in method 4. I'm not supposed to do anything. Okay? Okay, let's talk about Lambda expressions. Lambda expressions are like expressions. It's a function, so instead of me going and defining a function which really static and get product of two integers as such and return a times b as such, this required like a lot of space. Well, in Lambda expressions, you could do so in just a single line of code. So let me show you what I mean. The keyword for Lambda expressions is the func keyword as such. Okay, so let's try to create a Lambda expression which does the same exact thing as get product right here. So right here goes your function inputs int, and after your inputs goes the output int as such. Okay, right after that goes your anonymous method name get product, and is equal to, right here you define the inputs a and b, and with an equal sign and a greater than sign, after that goes your output, so a times b. This is a definition of an anonymous function which does the same exact thing as this function or method right here. Let's give it a try. Console.writeLine, say I want to compute 4 times 5 using my anonymous function. So get product 4 and 5 as such. Run to make sure, and it's working. Another way to call your function is using the invoke keyword. Yeah, I forgot a bracket right here. So running that, I get the same exact output. Okay, let me show you another instance of using anonymous functions. So let's say you've got a list, right? So a list of integers, and this list is just some random numbers. And let's fill it out right here. So 1, 2, 3, 4, 5. I would like to, return all integers that are even. You can do that in one line of code. So list int even numbers. And I would like to extract the even numbers from random numbers as such. So all I have to do is call the where function, which is an anonymous function. And all I have to do is do something like this. So I open brackets as such, and n would return for each integer. I would like to return it if it is even. So n modulo 2 is 0. And it's yelling at me because I need to convert it to a list, right? So to list, and all should be good. Now let's print it. I think you could print it as such, but if not, we'll have to extract them one after the other. So no, you cannot print it as simple as that. You'd have to run a for each loop and extract each number int a and even numbers, and then print each number separately. 2 and 4 are the only even numbers in this list. This right here is another instance of anonymous methods. So you're defining an anonymous method right here. Okay, let's talk about structs. So what structs are, what's a data type or a custom type, I would say, because you're, fabricating this data type, you're imposing the properties and the methods of this data type. So it holds multiple values and it also can perform multiple functionalities depending on what you specify. So let's give an example. You can define it outside the scope of your program, and let's say I have a struct which has the name account, right? So we have a bank account and it has some properties and it also has some methods, right? So the properties you can think of here are simply, let's say, an ID. You can give any account a certain ID. You can also give it an amount, because every bank account has a certain, right? So a certain bank account can have $20,000, another one could have $200,000, and I hope yours reaches $2 million, right? Being optimistic here. Also, the bank account could correspond to a certain owner. So the owner is a string. Can't do much about this. So we can't, let's say, define it as an enum, because names have a lot of, you can come up with a lot of names. So the only thing you can think of right here is a string, right? Good. So your account has those three properties. Let's think of something else. I'm thinking maybe it could have a certain branch. Let's say your account is in this city. Let's call it city instead of branch. So let's say you have a certain bank that has multiple branches, and each branch is in a certain city, right? Yeah, you would like to know where your bank account is, in which city it's created, right? Well, at least that's the case in France right here, because in France we have multiple banks like Société Générale and BNP and so forth. With Société Générale, you have a lot of branches. Branches are usually city specific. Good, so I'm okay with those four properties. Before we create some methods, I can just go ahead and, create an account from the main scope. So account, and the name of it is lowercase account, is a new account, right? Now at this moment right here, my account is empty, ID is empty, amount is empty, owner is empty, and city is empty. To demonstrate this, let's just go ahead and print ID, for example. And you can see right here that also it's inaccessible. I'm not going to talk about this right now, but just forgive me for putting that. Let me just add it right here. So running that, you could see the ID is 0. This is a default value that C# gives us. Amount is also 0. Let's see what owner holds. It's empty. And let's see what city holds. It's also empty, right? Okay. So you can go ahead and, fill the properties right here. So ID is 10, let's say. Account.amount is 2 million. And account.owner, let's say, is John Smith. And John is living somewhere close to San Francisco. So if we go ahead and print the city, we should be able to see this San Francisco right here. We want to print ID. We should see 10, right? Okay, but this is a really messy way of doing stuff. It's not nice. Let's say you have you're working on a really big application or really big software, and really looks really ugly. So what people tend to do is create a certain function that, if you're familiar with classes, it's a constructor. So this function, what it does is fills up the values. So instead of saying that in the main scope, your values, you just fill them within the scope of your struct, and more specifically within the scope of your constructor. So void, let's say create account. All we have to do is just pass it the properties. Good. So now you would want to affect the values of the arguments to the properties of your struct. So what you can do is this dot ID is ID. So the difference between ID and this ID, this one over here is an argument. You're giving it to the function, right? And this ID right here is a property of your struct. So the way you access a property of your struct is using this struct right here, dot the ID. And you want to insert the value of ID within this dot ID. Another easy way of doing that is instead of complicating and having two same names, right? You can just go ahead and say ID is D. So now this ID stands for the account property ID, and this D is the argument of the function or the input of the function. And what you'd see most commonly is this notation right here, so that oh, I want to fill this amount right here, I want to fill the owner right here, being consistent. Okay, now let's do the same thing for amount, same thing for the owner, and the same thing for, city. Let's insert some other functions like add amount. So let's say you want to add a certain amount to the existing amount. Int value to add. So what we want to do here is just add value to add to amount. The way you can do this is this dot amount, or simply amount is amount plus value to add. And in that case, your amount will be increased by how much you give it as input. Let's say the user of the program accidentally inputted a negative value. So let's go ahead here and type a message saying value to add is negative or equal to 0. Print the following message: you should add a positive amount, right? Else you go ahead and add it. Okay, let's do now the opposite. Let's deduct amount, right? So int value to deduct. I'll just copy paste the same code I have right here. And here, if the value is also negative, you should pass a positive amount to be deducted, right? As follows. And why is it? Oh, okay, so it's a value to deduct, right? Okay, so in both cases, we should pass a positive value. And whether it's positive or negative is understood from the name of the function. So when you want to add, so naturally you'd add, you'd perform a plus operation. When you want to deduct, you'd perform a minus operation. Okay, so those are some operations you can do with the account. And let's just implement the final, or before the final function, let's implement a Boolean function that returns is broke. I want to know if this account is broke or not. So it returns a true if it's broke, else it returns a false. So if amount is strictly less than 0, return true, else you would want to return a false, right? Okay, looks good. Now let's implement a useful function called print my properties. It prints the different properties that we have, which are 4 properties right here. So we have an ID, and let me copy paste this 3 times. The second thing I would want to print is the amount, right? Third thing is the owner, and last but not least, the city. So this looks really good. I'm just going to go ahead and fold my code because I'm used to that. It looks really nice when folded so that we can, have a good overview of the struct. Okay, so now I can get rid of all this and let's do the equivalent operation using the create account function. And as you can see, auto-completion is not recognizing create account. And the reason behind this is that if you don't specify it, it's a protected function. So what that means is that you cannot access it directly like this. If you want to access it directly, you should use this keyword right here, which is public, which means let's open this function or method or even the property to the public. And that is why right here, again, going back to this ugly block of code, that is why right here we were not being able to access ID unless we specify that it's a public. So let me remove public. As you can see, it's yelling at me right here. So other keywords are also private. Private is more hidden. It's private, it's what it is. So you cannot access it. Right? So let's keep them all public to access them. And now that you should not only does it look ugly, but also due to some stuff I'm not going to go through over here in this lecture, this is due to some data encapsulation techniques, right? So instead of just filling the properties directly within the scope of the main, you do that using a function and keep your variables as private, right? So you do not want anyone to access those variables. So let me comment those out. Let me also comment this out. And now let me call the create account. And let's give it an ID of 10, value of 2 million, John Smith again, and the guy lives in San Francisco. Okay, now let me print the properties. There you have all the properties being printed out. Okay, let's perform some operations on the account. Let's say John Smith won the lottery today and he won a value of 400,000. 400,000 plus 2 million is 2,400,000. So running that, you can see that the value right now is what we just said. Now let's say John Smith was, I don't know, he got unlucky and he lost 3 million. So running that, he's broke right here. And let's call the isBroke method. It should return true or false, right? So account.isBroke, we should be able to see a true. There you have it. True, meaning that John Smith is broke. Let's go ahead and add another amount to make him rich again. So let's add a value of 10 million. Running that, you can see a false. So John Smith is no longer broke. And to prove that, let's print the properties at the end, print my properties as such, and you can see he has something like 9,400,000. Wow. Okay, so that's it for structures. Right, so let's cover FileIO. So what that means is that how could you read and write from files in your directory or from other directories? So the way you do that is using C# stream writer as such. And as you can see, it's not defined here. If you're using Visual Studio, an easy way to define it is Alt-Enter, and it's telling you should include system.io. So you hit enter and it's defined right here. In case you're using Visual Studio, that's a very easy way to do it. In case not, you'll have to write it on the top. So StreamWriter is the object or the class that helps you write or create a file. So let's say you don't have a file right now, you'd like to create it from scratch. Well, all you have to do is insert a certain, I call it a safe. You're trying to execute some code, but you're trying to check before if a certain line of code is usable or not, if you could execute it or not. It's like a safe way of executing some block of code. It's really similar to try and catch, exception handling. StreamWriter, and then you define the name of your object. So StreamWriter is an instance of the class StreamWriter, and you're going to create a new instance of your class. And as input, you will define the name of your file that you would like to create. So let's call it file.txt. It's a text file, and you would like to just simply write following line. This is sentence number 1. Running that, of course, you're not going to see anything here on the console, but you will see that a new file has been created from scratch right here. If I open it, I can see the sentence that I just wrote. Now let me just change this to a random number like this. So run, it has been changed. So when I write to a file, when I write to it, all previous information will be deleted. So let me enter some random text right here as such, save. Now let me run this program again. As you can see, all previous information is lost and new information has been written to it. Let me change this back to 1, and there you have it. Now let's do something more useful. Let's run a for loop for int I is 0, I less than number of lines, which I will define right now over here. So int number of lines, let's say it's 100. And each time I would like to, insert the number of the line, and this should go right here. Okay, so running that code, you can see I've got 100 lines. Okay, and in case you didn't notice what happened previously, let's say I don't have a file called file.txt, so delete, and let me run again. As you can see, it's created from scratch. Okay, if I open, I'm going to see all the information right here. Now let's limit that back to 10. As you can see, I have 10 lines, and let's say you have some information, right? So you've got an info file, and you would not want to rewrite from scratch. You would like to save those information you have. Well, all I have to do is insert a second argument to StreamWriter, which is the encoding parameter. And that tells C# that, wait a minute, don't rewrite the file from scratch. In case it doesn't exist, create it. And in case it exists, just write on top of it. Starting from the last line you have, write the following. So you set it to true. And remember, I have those written. Let me just input my own stuff, right? So as follows, and save it. Now if I run, I should be able to see those 10 lines on top of what I wrote. So as you can see here, I have this line written, at line 8. That's because when I wrote those, I didn't hit an enter right here. Let me save, and now let me run again. And as you can see, the 10 lines are written on top of previous information. Okay, good. Now let me just remove that back. So this is called appending. You're appending to a file. You're not writing anymore. You're just adding onto the file, which is called appending, writing at the end of the file. You're not rewriting from scratch. So we talked about writing, we talked about appending. Let me just, delete it because we didn't try that. Let's say I'm in append mode and the file doesn't exist. It will create it from scratch. Now I have this file. It has 10 sentences. I'm going to remove all this. And you would like to read from the file. So similarly, what we did before, you're going to run a using block. You're going to test if the following block of code will be executed because we're dealing with files. Files is not an easy thing to deal with. It's a stream of data coming in. So anyways, stream reader instead of writer, new stream reader. And all I want to do is, read from the same file. By the way, right now your file should exist. You can't read it from an empty file. The way you loop through your file is normally, you can do it with other ways, but normally it's done using the following while loop. And your condition of stopping your while loop is when you're at the end of your file. So how do you test that? You check if your sentence that is your streamReader.read line, so you're reading a line from your file.text, and you would like to check if this statement is null or not. So is my sentence null? If so, then we get out of the while loop. If it's not, we continue reading sentence by sentence. So in other words, we're extracting sentences from the file. And as you can see, it's yelling at me because sentence is not defined. So let's go here and define it. It's a string. We read from files as a string. In our case, because it's a txt, right? So this is good, looks good. And let's just, print to the console my sentence. Now let's say I accidentally, wrote the wrong name of the file. Run, and you can see here that you have an unhandled exception, system.io.file.not-found exception. So the file is not found. So to get rid of this, all you have to do is run a try the following and catch the exception. So exception, well, in our case we know the type of the exception, so we could write down here file not found exception, right? So in that case I would just like to print file is not found, could not read any sentence. So run, and there you have it. Let me change it back to file.txt. There you have your file.txt. So yeah, that would be it for this lecture. We covered a lot of good stuff. We did data types, UserIO. We covered conditionals. We also talked about looping, strings, StringBuilder, arrays, lists, and other interesting stuff. Now in the next one, we're going to talk about object-oriented programming, which is going to cover classes and method overloading, method overriding, virtual methods, and so forth. I'll see you in the next one.